Welcome back to the workshop. We want to continue taking a look at section 3.6, marginal distributions. And in this video, we want to consider when we have more than two random variables, in particular, discrete random variables for this video. Now, when we talked about having two random variables and we removed one, we were looking at a margin because we could take that table and just look at the left side or the bottom, sorry, the right side or the bottom. And so that was okay, easy enough. Well, if we're working in three discrete random variables, then that's a little bit different. If I remove one variable by adding up over all possible values of that variable, I'm actually still left with two variables. So when I remove a single variable, what I'd actually have left is called a joint marginal distribution of the two remaining random variables. So that's a little bit different. If I wanted to talk about the marginal distribution, right, not joint, just marginal distribution of one particular random variable, I'd have to add up over all possible values of both of the other discrete random variables. So it's a little bit different. So I'd like to take a look at an example. In the last section, we considered having or pulling three textbooks off of a shelf where I had 4 geometry books, 2 probability books, and 2 discrete math books. And we looked at the distribution of x being the number of, let's see, what did we say? X was, look at it here, the number of geometry texts, y the number of probability, and z the number of discrete texts. So we have the 3 random variables. And in this case, it's actually works out to be not super interesting, unfortunately, because we have this fixed number of books that we're looking at. It makes it work out so that way once I have 2, once I know how many of the 2 books I have, that tells me how many of the 3rd book I have. So there aren't actually any variations there, unfortunately. But if we were to bump it up to 4 books, then that could actually change things quite a bit. For different texts. So if we added some college algebra books in there as well, that would definitely change things up where we're looking at then 4 discrete random variables. But for now, let's look at the 3 and try to translate this into something a little bit different, right? The joint marginal distribution of, in this case, the geometry and probability texts. So let's take a look at our notes. So again, we've got the 4 geometry, 2 probability, and 2 discrete math texts. We're selecting 3 from the shelf. X is the number of geometry, Y is the number of probability, and Z is the number of discrete math texts. And we found a distribution for this back in section 3.5, and this is the distribution that we found. We couldn't give it in a nice table because there's 3 variables here, okay, X, Y, and Z. So what we can do now, though, is we can recognize that X and Y only take on the values 0, 1, or 2, 0, 1, or 2. So I can actually go ahead and create a table for this, right? Because once we remove Z, if I want to find the joint marginal distribution of X and Y, then removing Z, and what I'm left with is just 2 variables. So I can go ahead and say, all right, 0, 1, 2, 0, 1, 2, and create a table. Because now I do have just 2 discrete random variables. But the way it works out is we look for the situations where, right, I look for all situations where I have 0 of the geometry and 0 of the probability. And that only happens, oh, look, nowhere. It doesn't happen. So since it doesn't happen, the probability is 0. So I can move on and say, all right, let's look for all places where X is 1 and Y is 0. X is 1 and Y is 0. X is 1, so it only happens that one time. So the probability of that is the 1/14th. And like I said, since knowing how many knowing how many geometry and probability texts I have chosen tells me how many discrete math texts that I've chosen. So I actually am going to find that all the values on this table just appear once over on the joint probability distribution that we found in the previous section. So it's not super interesting, but we're looking for all occurrences of such things, and in other examples you would get more than just the one occurrence. All right, so let's look for where we have 2 and 0. 2 and 0, that's 3/14. And then 0 and 1, that's 1/28. And then 1, 1, 2/7. Let's see here. Okay, yep, 2, 1, 2, 1, that's 3/14. 0, 2, 0, 2, 1/28. And 1, 2, 1, 2, 1/14. And then 2, 2, of course I can't have because that's too many books. Oh, and you know what? I could have 3 of the geometry texts, though. I do actually have enough of those. So I need to fill that in as well. So let's see, 3, 0. 3, 0 would be 1/14. 3, 1 would be too many books. 3, 2 would be too many books. All right, so that's my joint marginal distribution. I've taken these, removed the variable z by adding up over all possible values. In this case, there's only one possible value for each of the pairs of x and y, because that value of z is determined by x and y. So it's effectively really just well, 2 degrees of freedom in this, if that sounds familiar, but essentially only x and y can vary. Z is determined by x and y. So again, maybe not the 100% best example, but still okay. So then what we can do though is we could also say, all right, well, we could find the marginal distributions of x and the marginal distribution of y. And once we've removed z, then we just have to remove the other variable in each case. So I could add up all these to get the marginal distribution of y, add up all of these to get the marginal distribution of x. Okay, so things really don't look any different. We can just remove one variable at a time by adding up over all possible values of that particular variable. All right, so that's all I wanted to share for this video. We've got one more video to take a look at where we consider a continuous random variables. So in this case, actually 3. All right, so I'll see you back in the workshop very shortly.